Going here. So this is our fourth session. Thank you to everybody who's coming back for this one. Now this one's going to be on networking and communications with the NJ and NX PLCs. We have on the agenda today is a quick discussion on the protocols that we can do. And then we're going to be focusing primarily on 3 different protocols here. So we'll talk a little bit about Ethernet IP, and then we'll walk through both explicit and implicit implementation. And then we'll do a quick OPC UA demo with this piece of SCADA software. And then we'll do some Modbus TCP, both client and server, and then a quick wrap up at the end with a question period. Now, this one is going to be hard for you guys to play along with. I am going to be developing a program as we go, and if you guys wanted to play along with me, you're more than welcome to. I am going to distribute a program at the end of the class that has all of the examples that I made in the program, so you'll have it for future reference. Because without actual hardware, your code isn't going to work, of course. So now, communication options that we support. So our NJ PLCs can support CJ PLC cards, and that opens up a few additional communication options for us. So we can do CAN, CompoNet, DeviceNet, Profinet, and Profibus, and those are specific to the NJ when they're running CJ cards. Now on the NJ and the NX, we have a few different options. So EtherCAT, if you guys remember from day one, we did an EtherCAT demo, Ethernet IP, MQTT, Modbus TCP, Modbus RTU, IO-Link, OPC UA, SQL, and kind of raw Ethernet and serial communications with devices comparable to, what you would do with Telnet kind of thing. Now, we won't have time to demo all of these today. We just picked the most popular ones, and not all of these can be done out of the box. So OPC or IO-Link, for example, we'll need a card for. Modbus RTU will need a card for. But all the Ethernet-based capabilities can be done out of the box. SQL and OPC UA are not available on all models of controllers, but on the NX102, kind of the one we've been developing our programs on, OPC UA is an out-of-the-box option on all models, and SQL is a model that you can get. It's an add-on, essentially. So Ethernet IP, probably pretty familiar to most of you guys. So it's a commonly used high-level communication protocol. So this is controller to controller, that sort of thing. But due to its speed and versatility, we're seeing it on all levels of the control system. So remote I/O, drives, sensors, that sort of thing. So very versatile, very easy to use, and it's one of the most widely supported protocols in the modern equipment. So we will be doing a demo on that shortly here. Now, there are 2 types of Ethernet IP, essentially, so implicit and explicit. Implicit messaging is where we set up a tag data link with something. We specify the instance we want. We use the EDS file in some cases, and that handles it behind the scenes. So we link up a tag set, and that the processor will automatically pull it at a requested packet interval for us. And we just get an error if we lose that connection. It's self-healing. If that device is plugged back in, you're essentially good to go. So very common. This is what you use EDS files for, is this type of Ethernet IP. Now, explicit messaging, this is the sort of class instance attribute type messaging you do. So you'd use this if you don't need to regularly read or write from an instance, you would use an explicit message. Now, I will be doing a quick demo here. So on the desk next to me, I have one of our intelligent power supplies, the S8VKX, and I'm going to be messaging it explicitly. So you guys are more than welcome to play along with me if you just want to make up some code demonstrating the explicit message. So this is our communication manual for that power supply. And the type of explicit message we're going to be doing is a UCMM message, so class instance attribute type message. So in the manual here, it lists everything we need to know. So our service code is a big one. service code down here, which is either get attributes all or get attributes single. We have our class, which is 372. We have our instance, which is 1, and we have a list of attributes we can get. Now I'm going to be going after a single attribute, but if I would have used the get attributes all, then I wouldn't actually have to specify the attribute. But for this example, I'm just going to go after the measured output voltage in this case. So if you guys would like to play along, please do. But like I said, if you don't want to, I'll be distributing this program at the end of class here. So all of our explicit message functions are built into Sysmac Studio out of the box. And I've got an NX102 PLC here, and it's a blank project. If you're going to be playing along with me, I suggest you do it on a blank project so we don't interfere with everything we've been doing so far here. So I'm just going to go to a blank project, a blank section, and I'm going to add a rung of code. And for this type of explicit messaging, there are a few options. I'm going to use SIP UCMM send for this one. There's also UCMM read, UCMM write. UCMM send is either a read or a write, and you specify which one it is. So put my block in there. I'll conditionally execute it here. Give the block a name. Now, the route path is something that's common to SIP messaging in general. If you've set up route paths on other platforms, it's probably going to look familiar to you. Now, if you remember from day one, whenever you're in doubt, press F1. So route path, if you don't happen to know what that is, there's an excellent help file for this, and it gives lots of information. If we scroll down to the example here, you can see our route path starts with O2. See if I can zoom in on that for you there. Yeah. So the route path for what we're doing here. So O2 is always port 1, and then a backslash, and then the target IP address, all within single quotations. So this is in the help file if you forget. Now my power supply is at .20, so I'll set up my route path here. So O2 backslash 192.168.250.20. That's my power supply. Timeout. Now service code, this is, if you recall from the communications manual, here we have our service code for the power supply for this particular monitor object. So either get attributes single or get attributes all. Now this is given to me in hexadecimal 0E, so I'll enter that as hexadecimal just to keep it easy to read. And my data type is a byte. So byte pound 16 because it's hex pound 0E will give me my get attribute single. And then we have a structured data type here, RQ path, request path. So this is a structure. Now it will create it as a structured data type if you put a unique data type in there. You specify that data type as underscore E. Sorry, underscore S. That's why it didn't come up. Underscore S. We have request path. Now, service data is data that we'll be sending to it, and it takes any data type. So I just tend to give this an array of some words. we won't be sending anything in this, we're just going to be reading. But if we were sending, then we would put information into that service data if we were setting an attribute versus getting an attribute. Now, size is the number of elements. And because we're using get attribute single, we don't actually have to specify a number of elements. So we can just leave that as 0. And then the RESP service data is what the power supply sent back to us. So I'll make another array there for the inbound data. Now I'll put an output on the done bit just to see if it was successful. And I'll fill in some of these tags here for troubleshooting purposes. Okay. Now you may have remembered seeing in the manual, we had class instance attribute information, but we haven't had a field on this block to fill in the class instance attribute. So all of that information resides in this request path structure. And if you remember from day 1, we talked a little bit about the embedded structured text in our logic. And this is a really convenient way to fill in structure members when you have to populate a structure with values. Instead of having a bunch of bulky move instructions in your logic, you could just have a couple lines of structured text, and it's a good way to clean things up. So I'll set this data on the first run. And I'll make a structured text box. And as I start typing the S8VK, I'm looking for the service data. As soon as I press dot, should be getting.
Aren't you looking for RQ?
Yep, RQ path. S8VK RQ, good call. Dot. Now here is the class instance attribute information that we put in here. So set these up. Okay, so now we can fill in all that information from our communication manual here. So our class is 372. Our instance is 1, and the attribute we're going to go after is 65. And these are all hex values, so we'll enter them in hex. But we mouse over, we see it's a uint. So uint pound 16 pound 372 was our class. Our instance, we mouse over that, is a uint as well. And that was 01. Attribute, which is a uint as well, was 65. Yeah. And this last item here is attribute ID. That's a Boolean, and that's true if we're going down to the attribute level. It would be false if we were doing a get attributes all instruction. So that would just be false. Okay, so we'll transfer this to my PLC now. There's a completely different project on my controller right now, so this first synchronize is going to take a bit longer than the next ones. Okay, so my transfer was successful, and you can see my first run bit switched all of these structure members to the values that I specified. Now they're given in decimal, but I specified them in hexadecimal, but they do all match up. I just realized I need to make this is attribute ID true. Just flip it there. Okay, so when I flip this bit, you can see I got the successful message here, and now it responded with 2 bytes of data. If we look at the manual here for instance 65, it's an unsigned integer, which is a 16-bit value, which is 2 bytes. And it gives us the output voltage, and we divide it by 10 to get the actual value. So we should have something like 241 on it. So if I want to look at the contents of that, I'll look at my response data here. So there's 2,410 is my value, and I have 24.1 volts on there currently. So that's correct. And if I were to toggle this over and over again, it would constantly update the voltage coming out of it here. And I'll just lean over next to me here and I'll adjust that a little bit. You guys can see it change. I drop that down, I'll message again, and now it's 23.6 volts. So that's how we do an explicit message in Sysmac. There are a number of other different explicit messages we can do. We can do tag-based explicit messaging from a controller, for example, and there are also the other flavors of the UCMM message. But this one's nice because you can have one block and you can do reads and writes both with it. So any questions on explicit messaging?
A question. So what's basically the meaning of the service code?
The service code?
Yeah.
Sorry, I didn't hear your full
Is
question.
What's basically the technical meaning of the service code? Is it the address in the device, the memory address, or what is that exactly?
So the service code is essentially what you'll be doing with the data. You're going to be either reading it or writing it, but if we look up service codes, there are a lot of different, just trying to find a quick overview of some here. Oh, maybe not. Anyways, so the service code is what you're going to be doing. So I specified 0E, get attribute single. So that tells the destination device that I want one single attribute, and the addresses that I filled in the class instance attribute is what I'm getting. If I would have specified get attributes all, then that would have sent me back this entire chunk of data here. If I would have chose get attributes all. Now, there are some instances in this controller, like this setting object here. So this has a write attribute to it. So I would actually use set attribute single there if I wanted to change it. So we have a different service code to write, a different service code to read, and in some pieces of hardware, you can send a unique service code and you could accomplish something like scan your IO-Link network, something like that. So it's nothing to do with the data address. It's more of the type of explicit message that you're sending. You're telling it what you'll be doing with that data. Does that make sense?
Yep, thanks.
Okay.
What data type is set up in SAVK variable?
So the data type in the attribute that we went after was an unsigned integer. Now, when we read that, we brought it into a word, which is why it looked a little funny when we were looking at it in hex 0938. But if we display that as a decimal,
Yeah.
then we can make that kind of human readable, right? So the data types, there will be some conversion involved when you're doing explicit messages. Implicit messaging, as you'll see, the next one we'll be doing here, we don't have nearly as much conversion work to do because we can use structures. But with an explicit message, we generally just bring that into an array of data. And then we sort of parse out and convert whatever we need to do. Do you know if we can use a structure on an explicit message, Mike?
I was just wondering that. I will look into that.
Okay.
Yeah, because when you define the SAVK, for example, SAVK RQ, it will ask you what's the data type you need, right?
Yes.
So for here, we don't have to define the data type.
So we do on our service data and our response data, basically our outbound data and our inbound data. The data type listed is any. So whenever that's the case, whenever it's not specifically stated, like this is an integer or this is a real, it will ask us the data type.
Okay.
So I picked word just because that's an easy one to work with. But I could have made an array of unsigned integers, and then I would have matched up completely with the SAVKX since I was reading an unsigned integer.
You can also use a structure.
Okay, good to know. So thanks, Mike. So if we were going to be explicit messaging something on a regular basis, we could actually put a structure in our service data. So we would build a structure according to essentially what's in this chunk of data here. So a handful of uints and then a couple double words. So we could build a structure if we were going to be doing this on a regular basis, and it would make our life a bit easier.
And if you were doing get attribute all.
Yeah, exactly. Get attribute all would have to be done for that.
Is that also where you would change the Boolean in the function block or in the structure to be false?
Yeah, if we were get attribute all, the attribute ID would have to be false as well. Actually, going to change that as soon as I go offline here. So. All right, so any other questions on explicit messaging? Okay, so next we'll do implicit messaging, and we'll be talking to one of Omron's machine vision cameras here. So just kind of a quick bit of information for what I've got going on beside me. So I've got a machine vision camera sitting next to me. You can see it's this is the live feed. That's my hand in front of the camera there. And we're just doing some OCR, and we're measuring the thickness of this little point here. It's not really important. What's important is on our Ethernet IP data links with the camera, we're making this OCR contents available, and we're making this measurement available. So our OCR contents is Omron, and our measurement is around 40. So we'll come back to that later. But when it comes to implicit messaging, you guys won't have the structure in your controllers, but in mine, I have ahead of time loaded in a structure that matches these input and output assemblies in my camera. So this was just basically done by looking through the manual and setting up the bit and byte offsets, as well as specifying all the data types and where they reside for both the input and the output. The example project I'll be sending out at the end, I believe, have these in it. So you'll have this for future reference. So this one's going to be a bit harder to play along with the way I'm doing it. But for an implicit connection, a data link, it's often called, the first thing we'll do is we'll set up two global variables as long as we're going after two instances. So this will be my camera input, and that data is going to be, what did I call it? Input assembly. So this is the structure that I built for the input assembly. Do one for camera output, and this will be the output assembly structure that I built. Now this is the important part with Ethernet IP data links, is this network publish column here. So by default, it's do not publish. Now, if I want to make this available for a tag data link, I have to change that. So my input assembly is going to be an input. My output assembly is going to be an output. And now what I'm going to do is go into Tools, Ethernet IP connection settings. Now I have 2 ports on this PLC. I'm only using port 1, so I'm going to double click on port 1. And now the first page it brings me to is the tag set page. The other tab here is the connection page. So the first thing we'll do is register our tag sets. And there's a button here called Registration All. And when you click on that, it browses your global variables and it detects any tag that you specified as either an input or an output, and it lists it here along with the size. So I'll go ahead and register those 2 items. So now I have my tags registered to my tag sets. I'll set up the connection with the camera. Now, if this is a third-party device, if we had to add an EDS file for it, we could right-click in the target device window here, and we could display the EDS library. And you can see here, I've got some third-party ones in here already, but we could simply click on install, and you could get the EDS file from the manufacturer. You could add it to Sysmac Studio and make your structures or arrays accordingly. So I've added a target device ahead of time here. So I'll double click on that, and that will add it to my connections window. And you can see this is the F430 camera. Now my target variables on my input and output are blank. So what most people like to do is type 1, and that will detect any instance that we have in the EDS file for that device. However, if your instance was below 100, that wouldn't work. So another thing you can do is Control Shift, and that will display all of the options for it. So we're using 102 and we're using 114.
Control space works too.
Yep. Yeah, I just mentioned that actually. So 102.
Oh, you said Control Shift.
Did I say Control Shift?
Yeah.
Oh, no, I meant Control Space. Yeah,
I didn't know about Control Shift, so that was
does
just
not work.
a mental typo.
Yeah, exactly.
Okay.
So yeah, Control Space. Sorry, I pressed Control Space and said Control Shift. So, but you can see once we select our instance, the size is auto-populated from what it reads in the EDS file. And the drop-down for originator variable is going to look for a variable that is that same size. So I have my camera input variable here, and the output instance, 114. I have my camera output variable. And everything else I'm just going to leave default. We can adjust the RPI if we want. Some connections give us a few different options, point-to-point or multicast, that sort of thing. But I'm just going to leave everything default here. This is done. So I'll go back online now. Synchronize with the controller first, just because I created those tags offline. Now I'm going to transfer the Ethernet IP connection settings that I just made to it. So registering the tag sets and that connection, I'm going to transfer that to the controller when I'm online. And I'm going to do it in run mode. We can do most of our Ethernet IP stuff in run mode without shutting down. Okay, so that's transferred to the controller. Now, a good practice thing to do here is go back to the first window that opens up when you choose Tools, Ethernet IP connection settings, and you can right-click on the port and choose Monitor, and it lists the target nodes down at the bottom. And if there was a red circle next to that, I would know that I've got a communication problem, and then I can look into it a bit more thoroughly in these other tabs here. But the connection worked. Now I'm just going to monitor that data. So I'll go to my Watch tab page table, and I'll choose the camera input. And I don't want all of this stuff, so I'm just going to clear and just pick a couple of different items here. So I have one floating point value, which is float, and I have one string. So I'm just going to display those three items here. I picked length, not string, sorry. And this float, not this float. There we go. So now if you remember from the camera, my OCR is giving me the string Omron. My measurement tool is giving me a value of roughly 40. Now in that structure, I look at the contents, and in the first string I have Omron, and in my first floating point register, I'm getting about 40. So if I were using a big array of data for this instead of a structure, I would be looking at 320 bytes of data that you need to find the index that you want, pick it out, parse it, convert it, whatever you need to do. So structures are always very useful in Ethernet IP. And if it's an Omron device, talk to your AE. He's probably got a structure for you. Any questions on implicit messaging? Okay. I guess just a quick recap on that one, because it's a very common one. So actually, there's one other thing I'll mention here. So you might not always have a structure for something, and you're curious what you need to create size-wise for it. So if I had an EDS file for from something, and I'll just pick one of the third-party ones I have. I'll just pretend this is a ABB. Actually, no, that one's variable. I'll pick a laser marker. Sure. Now, when I add that to my connections, if I'm curious how big I need to make a variable before I pair it with it, I can choose the connection, and I can choose an instance that's available, and it will tell me that I need 96 bytes for input, and I need 92 bytes for output. So now I could go into my global variables, I could make a 96 byte array and a 92 byte array, specify input and output. And this is kind of a quick and easy way to just verify the connectivity with a device. You can go about making your structure after, or if you only need one data point out of it, it's probably not worth making a structure for. So it's just kind of a quick tip for you. We'll go offline with that one now. Any questions on implicit messaging?
In some EDM files, you have different options of, for example, exclusive owner, or just basically reading the data, or having different packages of data. How could we basically choose it in the Sysmac what type of connection we want to have?
I'm just trying to think of an EDS file that has those options. Well, those are usually options just try to, maybe the laser marker has one here. Yeah, so there are different options in your connection IO type for those sorts of things. And there's also, you can see this one here on the laser marker, we have multicast and we have point-to-point. So if they're specified in the EDS file, you'll have options in the connection IO type column here, and you'll have options on the connection type here. And there's no, you can also have data links with the same IP address if you wanted multiple instances as well. If you're trying to accomplish multiple instances, we can read .40. We can have several connections to 250.40 here, going after different target variables, different instances each time. That answer your question?
Yes, and just basically opening the EDS file, could we find the same attribute ID or any other info that we need for implicit connection, or so it's basically the same info that we could find in those manuals or in the EDS file as.
For the most part, yes. So each of these instances and their sizes and what type of connection it is, this all comes from the EDS file. So if you were to open it up, you would be able to drill down to these target variables here, and you would see all of this information on it, the size, the connection type, RPI. Just pop open a program here to show you what I'm talking about. Sure, where I have EDS file. Okay, so I grabbed an EDS file here. So yeah, if you drill down into this EDS file, you can see those are the two assemblies, 100 and 101. We have our capacity. We have RPIs, input size, output size, all of that stuff. So you could derive that from the EDS file if you wanted to. That's all Sysmac is really doing. I'm not a whiz at decoding EDS files, but hopefully that answered your question. Yeah,
I usually just open it with the notepad. What is that software?
This is EZ EDS. So it's, I believe the ODVA developed it. Yeah, so this is from the ODVA, who's kind of the governing body for Ethernet IP. So this is kind of an EDS file interpreter, editor. It's free. It's from the ODVA. So it's, sometimes you do need to modify EDS files. Sometimes you want to make your own. So it's useful for that. But
thank you so much.
Notepad works too. Nothing wrong with Notepad. Okay, any other questions on implicit messaging? Okay, OPC UA. So this is an option on several of our controllers. And this is another protocol that I believe the ODVA manages. But essentially, it's a client-server-based communication protocol. And in the case of our PLC, we are the server. We're the OPC server, and the OPC client is commonly a SCADA system. Now, there's a lot to OPC UA. This would be an entire PowerPoint on its own, but essentially how we set all this up is in our NX102 projects. You may have noticed the OPC UA settings in the Multi-View Explorer. And you guys can play along here if you want to enable your OPC UA server. So if we double click on that, I believe it's turned off by default. But if we flip that to use, that will turn on our OPC UA server. Now, once our server's on, we need to decide what tags we want to actually serve to the outside world. And this is where the other option in our network publish column comes from. So input and output, we use these for implicit connections over Ethernet IP. But publish only is what you do when you want to make a tag available for OPC UA. So I'm just going to make a few new tags here. I just made a handful of tags here with the publish only attribute specified on them. So I'm just going to transfer this to my PLC. Now, this is something we can do with an online edit as well. If we wanted to create a new tag with the publish only attribute, we could do that as an online edit as well. Now, that little pop-up that keeps coming up about OPC UA, that just means that the last project that I had on this controller had it disabled, so I actually just need to restart the controller. This is a one-time thing just because it was disabled prior to having this program put on it, so I can just put it in run or program mode, sorry, reset the controller. It's going to go offline. PLC's rebooting. Give it a second here. And we're back online. So how we sort of double check what's going on with our OPC server at a high level, if we right click on the OPC UA server settings, we can choose server status. And it tells us that we're using our server, the server's running, and it also gives us this endpoint URL here. So this is going to be what we use on the SCADA system to point to our OPC server on the network. So I'm just going to copy that. Now for the SCADA side of things, I'm going to use Indusoft Web Studio. Some of you may be familiar with that. It has OPC UA client capability built into it here. It's just booting up on my other monitor right now. So this is Indusoft Web Studio. I've done this on Ignition. This works on Ignition too. It's a fairly similar process, but when we're setting up our driver, you can see we have an OPC UA driver, and we can insert a connection. We'll call this our NX102 PLC, and this endpoint field right here, this is what the OPC UA endpoint is. So I'm going to copy that from Sysmac Studio. I'm going to paste it in here. And I don't have security enabled or encryption or anything like that. This is just an unencrypted test connection. So I'll click on test connection, and you can see it's established the connection to the PLC. So I'll hit OK. And now what's nice about OPC UA is this will have a tag browsing list built into it. So when I browse for a tag, and I choose to browse my PLC, when I browse, I can drill down into all of the tags on that PLC, the global variables, and you can see here I've got all 4 of those variables that I made. So I'm not importing and exporting a CSV file with all my variables on it. I can pull the variable list from the PLC, and they're available by name through my OPC client. So that's essentially OPC in a nutshell. And if I were to make a new tag on my controller, just do it as an online edit. Transfer that. So now the next time I browse my OPC UA server, you can see I've got my new tag right there ready to go. So this can expedite development quite a bit. Any questions on OPC UA? Okay.
Question. So the Ethernet IP you set up like this one, the variable camera input, the network publish is set up for input. So which means this variable it's output from camera to the input of PLC.
Correct. Yeah. This is from the perspective of the PLC.
Okay.
Yeah. So from the perspective of the camera, there's actually an output assembly 102 and an input assembly 114, but we're always doing it from the perspective of the PLC.
Okay.
And that's something that's very easy to get backwards with some documentation. So that's a good point. Okay, Modbus TCP, classic Modbus. So if you guys are playing along here, what I will get you to do is our Modbus TCP is done through a library. And if you guys remember from the intermediate class, to add a library to our project, we go up to Project, Library, Show References. And in the file that I had everyone download, I've got a Modbus TCP library in there. So it's in the student material 2022. It's in PLC libraries. Modbus TCP. And then MTCP_NJNX is the name of the library. So we can go ahead and grab that library and add it to our project. Hit OK. And now when we're in our logic, we have our MTCP_NJNX library in our toolbox ready to go. So I'm just going to make a new program for this here. So Modbus TCP is similar to explicit messaging in that we have to trigger our instructions from within logic. So if we look in our Modbus TCP library here, you can see we have client connect. We have a handful of functions. These are all client functions. And then at the very bottom, we have MTCP server. So we'll do a quick server demo after we do a client demo. But when we're doing a client, the one block that we need, regardless of the function code, is the MTCP Client Connect block. So I'll just give this a name here. So I'll be going to my SAPK power supply again. And the IP address is going to be the IP address of the power supply. Port is almost always 502. I think if you leave it blank, it defaults to 502. Oops, that's not a string. And we have a variable here, a Boolean variable. That we can use there. So I'll put in some troubleshooting variables. Okay, so socket status. This is what will tell us the connection state at any given time. And this TCP socket variable is what we are going to pass to the functions, the function code, function blocks. And this is the information on where it has to route that packet, essentially, where it has to route that function code, that request, that read, or that write, whatever it might be. So now that that's done, I'm going to put a rung below it, and I'm going to do an FN03 function 3, which is read holding registers for those of you familiar with Modbus. So I'll drop that on the rung below. And now the first variable is TCP socket. So I'm going to take the same socket variable from the client connect block, and I'm going to give it to the TCP socket input on this function 3. Now unit ID with Modbus TCP is almost always 255. Now the register address we'll be going after. I'm going to go after register 1 in this case. The register quantity, I'm going to grab 5 registers. And then send request is what we use to actually operate this block. So put a bit there for success indication. Some troubleshooting bits. Okay, I'll transfer this to the PLC. And I'll pull up the communication manual shortly here, and we'll show you what we're actually doing going after register number 1 and quantity 5. Okay, so this is the communication manual for the SADK-X, and this is the Modbus TCP section. So if you remember, I'm going after address 1, which is the same piece of data we were getting before, the measured output voltage, only I asked for a quantity of 5. So I'm going to get 1, 2, 3, 4, and 5. And those are all going to be brought into my FN03 data array here. So I'll add it to my watch window. And it's a large array of words. I'll go ahead and the first thing I'll do is turn on the connection block. Now, obviously, in the real world, you would be interlocking all of this stuff. You wouldn't enable the function 3 unless you had an established connection with it. So you can see my socket status has changed to established. And now I'll enable my function 3. And it was not happy with that. Oh, no. So I actually, this bit down here is what we toggle. That's right. I'll toggle that. It's reported success. And now in the contents of my watch window, you can see I have that same 23.6 volts. And if we were to go through the rest of this data here, we would be able to figure out what exactly it meant. But that essentially, those 5 words that came back correspond to what we were looking at here, starting at address 1, and then the next 4 sequential addresses. So the downside of Modbus TCP is when we get the data from it, we only have the option of bringing it back as an array of words. So with Ethernet IP, with SIP messaging, implicit and explicit, we could bring it back into a structure if we wanted to, but we don't have that option here. We can only bring it back into an array of words. So there will have to be some conversion to and from words when you're using Modbus TCP. Any questions on Modbus TCP so far? Okay, so that is Modbus TCP Client. I'm going to close that connection here. Now the next one we'll do is the Modbus TCP Server. I'm going to go offline for that, and I'm just going to add a new program section, and I'm going to call it Modbus Server. For Modbus Server, it's just a single function block. It's pretty easy to set up. You have a variable for registers, which is 1025 words. And you have a variable for coils, which is an array of 1025 bits. Those all correspond to when somebody asks us for register 1 or register 0, sorry, that's array position 0 in this array, whether it's a coil or a register. The function code that we receive will determine where we serve that data from, either registers or coils. So we'll make variables for both. Okay, I'll transfer that to my controller. And I'll zoom in a second here, so if you guys are following along, you can make a copy of that. I'll go ahead and synchronize. Yeah, just looking through chat here. Mark, you asked about the library. I believe Omron France is where this is hosted. I believe it's on myomron.com as well. Okay, so with the Modbus TCP server code all synchronized, to start the server, we simply flip that bit, and now we're basically waiting for a connection. So I have some Modbus software going, a Modbus client software running on my computer here. So I'm going to set up a Modbus connection to 250.1 on port 502. I'm going to hit OK, and you can see in the background, as soon as I hit OK there, connected became true, and this is also relaying the IP address of my laptop right now that tells me what client is connected to it. Now, as far as the data that's being displayed here, this is register 1 through 10, because I've asked for 10 holding registers. I could ask for the coils as well. I'm just going to go after the holding registers here. Now, in registers here, this array, I'm going to add that to my table. And I'm just going to put some data in there for test purposes. So 1111, 2222, 3333, and FFFF. So if I go to the Modbus software now, it's automatically polling this particular piece of software, but you can see here this Modbus client at address 40,001, it has 1111, 40,002 has 2222, et cetera, et cetera. So pretty quick and easy to set up a Modbus server. The function codes that we respond to are, I believe, 1, 2, 3, 4 we respond to. I can test the coils here quick. So I'll just flip every other bit. And now in my Modbus software, I've got 10101. So when you're going for either coils or inputs, so 10,000s or zeros, that's what our coils array is serving. And when you're going for input registers or holding registers, 30,000s or the 40,000s. That is what the registers are serving. And you'll see behind me here, when I close the connection, the block is no longer connected. It's indicating it's no longer connected, and the status is closed. So pretty quick demo of Modbus TCP. Does anybody have any questions on Modbus TCP? Okay, and just so just so everyone on the call knows, as well as anybody who happens to stumble upon this video on YouTube, the library MTCP NJNX can be found online on Omron France's website, and it's the most up-to-date. It works on all the NJ and NX CPUs. Okay, so today is usually a pretty quick one, simply because nobody can play along. You're basically just watching me do it. But to kind of wrap things up, for OPC UA.
Excuse me.
Yep.
If I connect to not to the server but to the robot controller, we will follow which function? The function of the server field bus or something else?
So most of the time when you're connecting to a device like a robot controller, you're going to be using the client functionality. You're going to be the master, if you will, commonly called the master. If you were...
which function exactly?
Well, it depends what data you're getting, but it will be the...
I think the data will be in two directions, between the robot controller to the PLC and from the PLC to robot controller, carrying like bytes of information, most of them digital inputs, outputs, but I think they may carry something like coordinates, so it will carry something like array or something like that.
Yeah, so probably coils and registers you'll be going after. So function 3 is for registers, and you'll be using a different function for the coils. I think it's 1 or 2. I don't remember off the top of my head, but if you look at the Modbus standard, it will tell you. So you'd be using this function for likely the coordinates in that case, numerical data. And for the input statuses, you'd be using the read coils function. And again, sorry, I don't, off the top of my head, I don't recall which function that is, but.
I just dropped it in the chat.
Okay, perfect. So yeah, either function 1 or 2 in your case, or 4. Nope, sorry, not 4. It would be 1 or 2 coils or discrete inputs, function code 1 or function code 2. Thanks, Mike.
Yes, thank you.
Any other Modbus questions before we get to the summary here? So was that a question, Sharif, or did you leave your mic on?
Yes, but I need to test it first. So I will take this information and I will start to work on it.
Yeah, and you know, it can be a bit cumbersome when you're doing some guesswork with a PLC. What I usually tell people to do with Modbus when you're kind of feeling things out is use a PC-based program like ModScan or MDBus. There are countless free Modbus clients out there, and it's a lot easier to type different registers and scan different ranges and see which function codes are responsive using PC software, and then you can simply replicate that in the PLC once you sort those out. But
You are right. Yes.
yeah, so just a quick summary of the function codes somebody posted in chat. It's a good thing to know. So these are the most of the standard ones here. Function code 1, read coils. Function code 2, read contacts. Function code 5 is write a coil. Function code 15 is write multiple coils. Function code 3 is read holding registers. Function code 4 is read input registers. And the address range on the right-hand side should look familiar because that's what was displayed here on the address range. So holding registers are 30,000, input registers, or sorry, 40,000, input registers are 30,000. Coils start at 0, and input status starts at 10,000. So the PLC appends that 10, 20, 30, 40, whatever it is, 1,000 onto its data when it sends it back to the client from the server. So.
Did you shave something? Did they shave something? Did you shave something?
Just for clarity, does it append it onto the address in the communication command? So if you put 1, it'd be 40,001.
Yeah, so it depends on the function code, but if we were doing read holding registers, which is function 3, we would be, so 40,000 would be appended onto number 1. Number 1 is array index 0 on our PLC. And if it was a holding register request, it would append 40,000 onto it. If it was an input register request, it would append 30,000 onto it. So we treat input and holding as the same. We just append that 30,000 or 40,000 onto it. So in some cases, you do need to, if you were on a different client reading our server, you would often need to add that 30,000 or 40,000 onto the address that you're requesting.
I was thinking from our side, if we were the client. So yeah, you put a 1 there, that would read.
Yeah. So the client, we do the same thing.
Okay.
So yeah, I haven't sniffed the packet to see if it, what exactly it requests, but I believe function 3 is a 30,000. Let's see.
TCP.
No, that's a 40,000. So yeah, we append 40,000 onto everything we send out with our function 3. Okay, so we're got about 15 minutes left here. Just kind of a quick summary on what we talked about today. So OPC UA, if your PLC supports it, you simply enable it. You publish the tags that you want by specifying the network attribute on it, and then you're finished. The rest is done on the SCADA side of things. With Ethernet IP, we have to do a bit more work. We have to set up our variables first, and then we set up our data links. However, the communication is handled automatically, except for explicit messaging, the class instance attribute type messaging. And that is, excuse me, done through logic, just like Modbus. Speaking of Modbus, both client and server are fairly manual protocols to implement. So you see every message that we send out, every function code message we send out has to be triggered. We have to monitor responses. So be cautious of that when you're implementing it. The server is a bit more simple. That is kind of manages itself behind the scenes. You need 3 tags total to use it if you don't want any of the troubleshooting information. And that's it. So I usually have a lot of questions on the communications unit. So we've got an extra 14 minutes to go here. Does anybody have any questions regarding communication capabilities or anything like that, we can kind of have an open discussion right now regarding it.
I have a question about the library? Yeah, so when I generate the library based on the controller device is a NX1, suppose it's based on NX102, and so this library also can use for NJ101 or NX1P2, or
Correct.
only for the NX102?
Nope. So this particular library that I had everybody download in that student files, this is for any NJ or any NX PLC.
So NJ and NX can share the library can share the library, right?
Yeah, it could be compatible with both NJ and NX. Yeah.
Okay.
And I'm actually on a very old firmware on this PLC. So,
Uh-huh.
and it has no problem with it. So I don't think you'll ever run into any compatibility issues with the Modbus library.
Okay. Because because when I create a library, it asks me enter the device and also the version, right? Yeah. So
Yeah.
okay.
And every time you let me go offline here. And every time you add a library to it, there's a bit of a disclaimer here. So if I threw on my MQTT library, you know what, it might not be the right version. Anyways, there's a bit of a disclaimer every time you add a library. It says some of the instructions might not be supported by your controller revision sort of thing. So when you're making your libraries, set the revision as old as possible. And there really aren't that many instructions between the NJ and the NX that aren't intercompatible, interoperability between them sort of thing. So you generally don't run into too many compatibility issues with libraries between NJ and NX.
Okay, got it. Yeah. And yeah, the second question is any possible the PLC can generate the TXT file? I mean, not generate a TXT file into the PLC. I mean, generate a variable and save this variable into the PC through the Modbus or TCP/IP, and save this value in the TXT file. Because I have used one device, it doesn't allow the Ethernet IP. It only allows the Modbus TCP/IP, and only read the data from the TXT file. Yeah. So my question is any possible the PLC can generate the data and save into the remote PC into the TXT file?
Yes. Yeah. Talk to me after if you want, and I'll get you some example programs on how to do it. But essentially, we can save TXT files to the SD card that's built into the PLCs. And then we can send that file over FTP into a computer.
Okay.
And I have an example of each of those. You could kind of merge together if you wanted to accomplish that. I could send them to you after if you want.
Sure. Okay. Yeah. Great. Thank you.
Yep. Any other questions from anyone on anything communication related?
Yes. Regarding this lecture, we will have the video as usual, and next time it will be last time and those sessions. Yes.
Yeah, I'll distribute a PowerPoint. The PowerPoint that we had, a recording will be distributed as well as this as an example program. So I should probably kind of tell you guys about that right now. So I'll be sending out at the end of the session an example program. So this is kind of something to have in your arsenal for the future. So we have an example of how you implement a PID loop, we have an example of the Modbus TCP client, the Modbus TCP server, tag-based Ethernet IP, class instance attribute-based Ethernet IP, as well as bit extraction and how we do all that. So I'll distribute this example program along with the lecture video and the PowerPoint. So you'll have everything you need to kind of come back and review this in the future, as well as an example program that you could cut and paste from if you wanted to. So.
Perfect. And for how long you will keep the shared folder? Because you share everything in folder. For how long you will keep this shared folder active to us?
Didn't really have a time frame in mind. Probably a couple months at least.
Oh yes, thank you so much. That's it. I don't have any more questions because this lecture, it's very heavy and it has many things behind because it has too much information we should to know. That's why to know why you are select this number, not that number. So we need to have too much we have to read too much to figure out all segments because you went through the communication on glance. It's or too fast, so it's we need to read too much to know what you did exactly because it has some holes in the information.
Yeah, definitely. I could have picked one of these protocols and done an entire hour and a half on it. The idea here was, like you said, you can go back through the video and see how something was done. I think that's kind of a more valuable reference tool down the road versus being an expert on, Modbus TCP and Modbus TCP only sort of thing.
Yes.
Thanks for the feedback.
Yes. And for example, the OBC server, I defined the OBC server before. I took like 2 days to finish the definition of OBC server for the DCS system. So you went through the OBC server here just for like 3 or 5 minutes. So I have to read the what is the background of this exactly.
Yeah, with OPC, the vast majority of it's done on the client side, and that's going to be different on every platform. So
exactly, yes. In ABB, it's something different, totally different. Even the interface software, it's different totally.
if no one's got any more questions, I'd be more than happy to give you 5 minutes of your day back. Next session is kind of optional. We're going to have account managers and AEs on the call. So if you have any projects in mind or any questions about any of the sessions that we've had, bring them along. And thank you to those of you who won't be coming that day. Thanks for attending thus far. And again, feel free to reach out to me if you have any questions in the meantime.
Stu, sorry, one more question. So,
yep.
Are you going to introduce some like alarm message for the